Hi, this is Alex from devstories.eu. Azure Pipelines, Episode 9 of 10. You can easily write a standard pipeline job that runs a shell script to push code to a server. But when a critical bug hits and someone asks what exactly went into production last Tuesday, that standard job gives you nothing but console logs. To get a real audit trail of what was deployed and where, you need targeting deployments with environments. An environment in Azure DevOps is a logical collection of resources that you target with a deployment. You name it something like production or staging, and it serves as the tracking anchor. Instead of using a standard pipeline job to push your code, you use a special keyword called a deployment job. When you link a deployment job to an environment, Azure DevOps automatically tracks the exact commits and work items that are being deployed to that specific target. You get a complete deployment history in the user interface without writing any extra logging logic. There is a major difference in how deployment jobs behave compared to standard jobs. A standard job automatically downloads your source code repository. A deployment job does not. It completely skips the checkout step by default. This trips up a lot of developers. The reason is simple. By the time you reach the deployment phase, you should be deploying a pre-compiled artifact or a container image created in an earlier build stage. You generally do not need raw source code on a deployment runner. If you actually need the source repository, you have to explicitly tell the deployment job to check it out. When you define a deployment job, you do not list a flat sequence of tasks. You wrap those tasks in a deployment strategy. The most common strategy is runOnce. As the name suggests, it simply executes your deployment steps sequentially against the environment. If you need something more complex, you can use the Canary strategy. Canary lets you deploy to a small percentage of your servers, monitor for errors, and then gradually roll out the new version to the rest. This limits the damage of a bad release. Inside these strategies, your tasks are organized into lifecycle hooks. This enforces a clean structure. First, you have the pre-deploy hook, where you might initialize resources or run database migrations. Then comes the deploy hook, which pushes the new version of your application. After that, the route traffic hook handles shifting network requests over to the newly deployed version. Finally, you can use post-route traffic to run health checks or clean up old resources. If anything goes wrong, there are also on-failure and on-success hooks to handle rollbacks or notifications. Take a scenario where you use the runOnce strategy to push a container image to a Kubernetes namespace. In your pipeline, you define a deployment job targeting your production environment. Inside the runOnce strategy, you use the deploy hook to define a task that takes your built container artifact and applies the deployment manifest to the cluster. You do not need to check out the repository because the container image is already built and stored in your registry. When this pipeline runs, the tasks execute and Azure DevOps records the action. Because it targets an environment, you can open the interface, click on production, and see exactly which commit triggered the image build, which developer authored it, and that it successfully reached the Kubernetes cluster. Here is the key insight. Moving from a standard job to a deployment job does not just change how your pipeline is structured, it turns your pipeline from a blind automation script into a fully traceable deployment history. Thanks for tuning in. Until next time.